it's the same stuff, okay, just maybe a little more complicated, but there's only so many exponent rules. There they all are right there. Okay, so we've been driving these exponents since Monday, 4 days now. Okay, your exponent driver's test is going to be Wednesday. If you've practiced enough driving, then you're maybe likely to pass the test. Okay, and if you haven't, well, you can always redo your road test, right? Next year, you can always redo your math course. Just because you don't do well on this test doesn't mean you're not going to do well in the course, right? It's just like 1/10 of it, what we're going to do in this course. Okay? Anyway, I'm not trying to scare you, but that's reality. First, we did product law, and this isn't the first time you've done it. This is grade 9 stuff. What is the rule? If I'm multiplying two things that have exponents and they have the same base, the rule says, what do you do with your exponents? You add them. Okay, that's just something, you can figure it out. I showed you how to figure it out. That's how we prove that the rule works. But if you just stick that in your noodle, it should be easy marks. Yes, the noodle's a brain. And you just used it, your noodle. Product law, quotient law. So if I multiply, I add. If I divide, then I... Yeah, and the first thing I like to do is, I hate looking at this thing. I like writing it like that. Because if it's a big, complicated question, it's a lot easier to visualize up and down, because you want to cancel stuff out, okay? But yeah, the rule says if you're dividing with the same base, here my base is x, I can subtract my exponents. Power of a power. Is anyone going to ask you, what is power of a power? No. But when you see this, you got to know how to answer it and get the mark. Okay? If this one is add, then this one must be times. Okay? There's only one base here. There's not two bases. There's only one base. That's power raised to another power. You multiply them. It's got to be something different than this, right? Okay? Power of a product. You don't really need to know that. But when you see this, you have to remember, and what did I say 17 times, Tyson? This exponent applies to... It might be both, it might be all three, it might be all four. So I don't want 6 different rules. Everything in the brackets. Okay? That exponent m applies to the x, and it applies to the y. Okay? If there's 12 things in there, it applies to them all. If it helps, draw the little lines one at a time. Okay? Nobody's going to say you're not allowed to do that in my test. I don't want to see no little lines. You have to do it all in your head. Okay? I'm not going to say that. Same thing. Power of a quotient. This exponent, if there's brackets, applies to everything in the brackets. You should hear my voice in your head when you're doing your test. Blah, 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 blah. Okay? Hopefully it makes more sense than that. Okay, that was all Monday. And then Tuesday we practiced all the same stuff. Okay? Then Wednesday we gave you this thing called integral exponent rules. Everybody going to get asked, what is integral exponent? No. What's another word for integral? Negative exponent. And I'm not even going to ask you that. But when you see this and the question says write that with a positive exponent, you got to know what to do. Okay? I'm going to put a 1 over that, and I've shown you that works. Okay? You don't need to prove it. You just need to know how to get the answer. Put a 1 over it, it becomes positive. Doesn't say it here, but what if it's already got a 1 over it? How do I make that positive? Flip it, yes. It's on the bottom. So you put it on the top. I still got a 1. Now I got x to the m in the numerator. Okay? Now it's positive. Everything stays the same. The base is the same. The exponent's the same. The only difference is it becomes positive from negative. Okay? If it's on the top, you flip it to the bottom to make it positive. If it's on the bottom, you flip it to the top. Do I need those ones there? No. 1 times that is just that. And over 1, it's just that. Okay? So I don't need all those. All right, and then yesterday we did something called rational exponents. You don't need to know that word. It's just an exponent, but this time it's a fraction. All fractions are rational numbers. That's why they call it a rational exponent. Okay? The question will say, write that as a radical. And I told you, okay, the bottom part of that fraction is the root part. And the top part is like the exponent part, the part out there. And that should be an easy mark. Okay? Stuff yesterday wasn't that difficult, was it? It's just kind of rearranging it. Once you do about 15 or 20, should be easy marks. Okay? Now, that's it. That's like all the rules there is to know. We just combine this one and that one, make it a little more challenging. Combine this and that, and maybe that one too, and it's a really, really hard question. But that's what you're expected to kind of know in grade 10, okay? So, read the question. Write each power as a radical. Remember doing this yesterday? The bottom part is the root part. The top part is the exponent part, but I don't have to write the 1, right? Is there anything else I can do? No, I don't know what x is. I can't evaluate it, like get the answer to it. I answered the question. It's now a radical. Negative y to the 5/4. Well, they love doing all these negatives in this book. Okay, gets a little confusing. Think bed mess. All right? Brackets, there's no brackets. Exponents, okay, I do the exponent part first. Subtraction, like a minus, you do that later, like last. In bed mass, subtraction is the last thing you do. So put the minus down there, forget about it. You're going to do it last. What's this? The bottom part is the radical part. The top part is the exponent part. And then I subtract it. And that's it. It's a radical. This one's a little different because the minus sign's in the brackets. Okay? So all of that is to this power. Here, that negative sign was not to the power of 5/4, right? Okay? It's just the y that's to the power of 5/4. So all of that has to go in here. If you like the brackets, fine, but you don't need them. The bottom part is the radical part, the root part, and the top part is the exponent part. Okay, the whole thing is called a radical, but that's fine if you think that way. Okay? Exactly the same thing. One's got brackets, one doesn't. What's the difference? Does this 3/4 apply to the 5? Then don't do that. It's just a 5. 4th root of t cubed. But here, it does apply to the 5. Okay, so then you want to tuck it in the radical. Okay? That's the difference. They're not the same. Okay? So, write them as a radical. Okay? Simplify. Write each expression as a power with a positive exponent, then as an entire radical. Okay, I got like 3 things to do here. Start with that. This was a power, and I made it a radical. Can I go backwards and make this radical a power? Sure. Okay, that's all we're doing. But first, what radical do I make that? Can I join these things together? Is there an exponent law we learned to do that? Am I multiplying those guys? Yeah. Do they have the same base? Then I can add my exponents. Okay? That's 3/2. This is, what's the exponent on this guy? It's a 1. What's 1.5 and 1? In other words, I know we all love adding fractions, but guess what? We expect you to kind of know this stuff. That is 1.5, 3 over 2. Okay, it's the same thing. If you like decimals, then 1.5 and 1 is 2.5. But we probably don't, because I got to write this as a radical. And what the heck do I do with that? Where's the bottom part? Where's the top part, right? It's not going to help me. Okay, so on the side, how do we do that? To add or subtract fractions, you need a common denominator, okay? So what's the common denominator here? Well, there isn't really a denominator. Let's give it one. I got to have a 2. How many times does 1 go into 2? 2 times. 2 times 1 is 2. 1 is the same as 2 over 2, right? So now I can add them. 3 plus 2 is 5 over 2. Is that the same thing as 2.5? Okay, some of you know that. And some of us, our strengths aren't that good, but okay, that's what you got to do. That's the same as x to the 5 over 2. That's simplified now. I only have one term. Can you write that thing as a power? I just did. Okay? It's a positive exponent. I don't have to do anything there. Finally, they want it as an entire radical. The bottom part is the root part. The exponent part is the top part. Okay? Same thing. I like looking at this like this. I'm dividing. I have the same base. What can I do with my exponents? If I have the same base and I'm dividing, I can subtract them. So that's 1/3 minus 5/3. Or, what's 1/3 take away 5/3? I got the same denominator, 3. What's 1 take away 5? -4. Simplified. It's a power. Is that a positive exponent? No. So you got this question yesterday. First thing you want to do is put 1 over it to make it positive. Everything stays the same, guys. Okay? I have the same base. Why? I have the same exponent, 4/3. The only difference is it went from negative to positive because I put a 1 over it. Okay, don't try to change it. Don't go like 3/4. I know it's confusing because we saw something like that before. Okay, that's all we do. Then, that's a positive exponent. What's that as a radical? 1 over the cubed root of y to the 4th power. Okay? It gets confusing. I was fine with math until it all was letters. Okay? Different color. Gets confusing. This guy. We've done this. Power raised to another power. Do I add these? No, I multiply them. Multiplying fractions, that's nicer than adding them because you don't have to worry about the denominator. You just multiply straight across. That's a to the 1 times 2 is 2. 2 times 3 is 6. Can I simplify 2/6? Yeah, then you do it. That's a to the 1/3. So then, that's a positive exponent, simplified. As a radical, anything 1/3 power, do you remember I said try to stick that in your noodle? What does that mean? Cubed root. But the bottom part is the root part. The top part is the exponent part. That works too. Okay? Cubed root of a. Okay, running out of room here. But first thing you should do, you remember the trick for D? If you flip this fraction, then this exponent becomes positive. Okay, that's your first step. And half power means square root. So I could take the square root of the top and the square root of the bottom. Let's go on to the next one. Right, quicker. Quick, quick. Oh, it's going, it's going, it's going. It's gone. Okay, a little bit bigger, a little bit uglier, exactly the same exponent rules. Okay? So split this thing up in your head. Don't look at it all at once. Break it up into little parts. Let me ask you, is that the same as this? Am I allowed to do that? Is 6 times 2 the same as 2 times 6? It's 12 in both cases. I can rearrange that. If that's what it takes to get the mark, then do it. What's 4 times 3? Yeah, just look at the numbers. Okay? Like I said, if it helps you to rearrange it, then rearrange it. Now I just have something like I just had up here. I'm multiplying with the same base, so I'm going to add my exponents. Over here, what is 3/4 minus 1/2? Need a common denominator? 4. 2 goes into 4 2 times. 2 times 1 is 2. Right? 1/2 is the same as 2/4. 3 minus 2 is 1. Same common denominator. Write it as a power. Positive exponent, check. And then as an entire radical, 12 times the 4th root of x. Okay? B. Split it up. Just look at the numbers. Did you guys know 5 divided by 25 3 years ago? You didn't? Someone said they didn't? 5 divided by 25? It's not 5. You got it upside down, but I see the way your brain's working. 5 goes into 5 once. 5 goes into 25 5 times. That's 1/5. Okay? That's all I can do with the numbers. Now you don't need to look at them anymore. Okay? I'm done with those. That's 1/5. Now just look at the x's. I'm dividing with the same base. I subtract my exponents. 3/5 minus the bottom one is negative 3/5, right? And what do you do when you see a minus minus? Make it a plus. What's 3/5 and 3/5? 6/5. I have the same denominator. I'm just going to add the numerators. Okay? As a radical, that's the 5th root of, not x, 6, x to the 6th power. Okay? Do I need that 1 there? No, I don't. So that's the same as that, okay? Which way do you like to see it? It doesn't matter. They're both right, okay? All right, how many more do we need? Okay, so this is what we did yesterday. This isn't anything new. The bottom part is the root part. The top part is the exponent part, okay? So we got it there again. But like I said, now we can go backwards. The bottom part is the root part. The root part goes on the bottom, and the power part goes on the top. Write it as a power in this form. And people get hung up with this part in that form. Does this look like that? Yes, it does, I'm going to tell you. It's in that form. Okay? This doesn't say it has to be a to the n, but a It happens to be a in this case. N here is the exponent. The exponent is 5/3. Okay? It's in that form. That's what it's asking you to do. Put this in that form. Okay? The exponent part is on the top. The root part's on the bottom. That's also in that form. What's the root part if it's not given again? 2. That's on the bottom. Exponent's on the top. Piece of cake. Billy. If we don't tell you, it means square root, right? Because back in grade 8, we didn't do that. All we did was give you one of those, right? That's square root. You only needed to know if it's something other than square root. Then we have to put it there. Okay, I got to make this look like that. This one's going to be a little trickier. It's 1 over, let's make this thing a power. So the bottom part is 2, the top part is a 7. Does that look like this form? Good thinking, yeah. It's not 1 over that form, it's just in this form. How do you make this look like that? Well, if I flip that up, it's going to be negative. Now it's in that form. N is minus 7 over 2. Okay? So you got to answer the question. We can ask you the same question 4 different ways. Okay? Okay, just a couple more. Because what do you do? We've seen this before. Square root of. Work from the inside out. Okay? So only look at this one first. Then do that one. Okay? So just look at the inside one. So that's 1296. The exponent, there's nothing there, so it must be a 1. And that's a 2. Remember, square root means the 1/2 power. Okay? But now I have another one, and square root means the 1/2 power. And if I have an exponent raised to another exponent, what can I do with those? I can multiply them. What's a half times a half? 1/4. It says evaluate. Now, that's pretty tough to do in our head. So, you know what? I'm going to cheat and use my calculator. What's 1296 to the power of bracket 1 divided by 4, or 0.25? 6. You think I'll get the same thing if I go the square root of 1296? Yep. Look at that. It works. Hallelujah. Okay? So, yeah, we need to calculate. I don't even know that, guys. Okay? I don't even know the square root of 1296. Yeah. Well, if I remember it. Okay, the cubed root of the square root of 64. Is 64 one of those cool numbers that's a perfect cube and a perfect square? Yep. Start from the inside out. Do you know the square root of 64? Yeah, it's 8. So now I have the cubed root of 8, which is? Yeah, so I'm actually cheating. I'm not writing it as a power. I better do that. It told me to. 64 to the 1/2, and then to the 1/3 power is 64 to the 1/6 power. Guess what 64 to the 1/6 power is? Yeah, we already know that, don't we? 64 to the power of 1 divided by 6. Just in case your mom asks you when you're having turkey dinner, hey son, what is 64th to the 1/6 power? Well, it's 2, Mom. Good boy. Here's some pumpkin pie. It's going to happen, right, guys? And girls? Of course it is. Okay, I think I pretty much got it covered. Let me just do one more. I want it to look in this form. Oh, let's do this one. Okay? So how do I make this thing look like that? Well, I got a 32x cubed, and all of it is under this 5th root sign. Okay, so both of these things is to the 1/5 power, right? Like there's an exponent 1 over there. They just don't have it. So this applies to everything in the brackets. That's 32. Multiply the exponents. 1 times 1/5 is 1/5. And x to the 3 times 1/5 is x to the 3/5. Almost looks like that, but a needs to be some integer. This isn't an integer. Anyone know the fifth root of 32? What times what times what 5 times is 32? Take a guess. It's got to be something small.
2, 4, 4.6.
4.6. Okay, 4.6 times 4.6 is already bigger than 16, right? Times another 4, bigger than 64. How on earth could it be 32 if I did it 5 times? 2. Yeah. All right. So 2. I know, it's hard. Does that look like that? And you might say no. Well, it does. Okay. A is 2 and n is 3/5. That is in this form. Okay. Good enough. You can watch me do 10,000 of these, and it's not going to help you at all, right? It's like watching me drive. Can you watch me drive and then know how to do it? How about a bicycle, okay? I'm going to ride a bike, someone's going to watch me, and then they go, oh, okay, I get it. And they're just going to hop on and ride away, right? Doesn't work like that. No.